Right, hello everybody. Let me introduce myself first of all. My name is Vasily Strelnikov and I'm a Senior Principal Training Consultant working for Oracle for 22 years, quite a while, doing all sorts of stuff, Java, web services, yeah, in this sort of middleware area. And today we're going to do this exploration kind of event, looking at Java versions 9 and 10 new features. It's a lot of material that we need to get through, so let's just, without any further ado, start with the content. Right, so objectives. First of all, there are two kind of big groups of objectives. One is looking at the new Java modular design, which has been introduced in Java 9. What are the modules, how it works, sort of, what are the principles, and some interesting features around the way in which we can now compile and execute Java modular applications. There's a very small topic on JShell, introducing that. It's a new tool that would make sort of a new style of command line interpreter for Java. Yeah, so we could look at that. And of course, another big area of this presentation, which looks into Java 9 and Java 10 language, API, and various management enhancements. All sorts of things, private interface method, private resource improvements, local variable improvements, introduction to the HTTP2 client, various API enhancements, and some Java virtual machine management and performance enhancements. Let's start. There's a lot of material here, so without any further ado, let's start on that. What's the module? Wow, this is the new modular design we have in Java 9 onwards, yeah? So module is kind of a high-level code aggregation. The idea is that you could take a number of closely related packages and possibly other resources, classes, images, XML files, grouped closely related resources packages. Describe them all as that group, as a module. That's done with a class called module info. So you create that class. You store that in a root modules folder. Each module must have a unique name, and it has to be universally unique. Obviously, the idea is that to ensure the universal uniqueness, you probably could use the same naming convention as you use for Java packages, which is reverse DNS. Take your company name, write it out in reverse, for example, com, dot, blah, blah, that's your company, yeah? And then whatever module you're trying to describe. So maintain that consistent naming to ensure its universal uniqueness. I'd say typically you probably select one of the packages from the module and use that package name as the module name. But it's not a requirement. Yeah? So it's likely to be the case. So you give it a good name. Then you describe what sort of objects, what sort of packages this module expert makes available to other modules, and which other modules this module depends on or is going to use, or relationships between these modules. You can describe these relationships in different ways. We're about to look at what are these different ways. Yeah, but the point is that if something you've got in a module, some package you've got in a module, is not exposed to other modules, well, essentially it kind of becomes private. Yeah, private and hidden within the module. So this is a brand new concept. In early versions of Java, we didn't have the idea of that level of code encapsulation. But now, basically, what you could do is hide implementation details of the module, which essentially not exposed packages inside the module, and only expose the bits you want to the external world, to other modules. As I say, there are different ways of doing it, which is known as opening modules and using modules, but also is another technique which is called services. You may expose the service from the module or consume services from the module, which is, again, something we need to take a look at. And finally, as it's crucial, modules will not allow you to split packages. Well, actually, that means very simple idea. If I've got some classes in a particular Java package, and I put them in one module, I cannot put other classes from the same package into another module. This simply won't work. Yeah? The idea is that such modules will be just rejected. You won't be able to run that application. And that prevents all sort of clashes between different versions of the application or different bits that you may have found in your class path, especially when you think about the evolution of your code. The fact that you didn't just produce all code in one go, but you keep producing it, you know, through a particular period of time and adding more classes. So essentially, with a modular design, you have to go and rebuild the module. You cannot just provide another archive with extra classes anymore. Yeah? You have to modularize it properly. Right. So you can see here a snippet of code, which is sort of a general way in which the modules look. Yeah. In Java, that's the module info class. Yeah. But we're about to study that snippet in more detail. So let's take a look. First of all, since Java Development Kit 9, we have a number of modules already built into the JDK itself. A simple command line, command Java -- list modules, yeah, could tell you what they are. So you can easily look at what exactly is in the JDK already. Examples of modules, well, there's one module that's probably very crucial, really. It's Java-based, yeah, which is the core Java language module. But there are lots of other modules which constitute this core Java standard edition runtime. Examples Java SC, Java logging, etc. Then there are JDK modules which provide additional runtime-specific features. So, for example, JDK HTTP server or JDK console or JShell, these are modules again. Yeah, a number of modules related to JavaFX runtime, and there might be miscellaneous modules as well that are supplied with Java Development Kit. Yeah, some of them still have Java prefix. Yeah, it's a naming convention adopted for the modules by the Java development teams. So the naming convention is that core modules are starting with the word Java, JDK modules started with the word JDK, etc. Yeah? So with the exception of two modules, which is Java JNLP and Java Smart Card IO, yeah, which also have Java prefix, all other modules will not have a Java prefix. Yeah, we'll have some other prefixes. And that's where you construct your own modules. If you want to construct your own module, well, you create module, info class, call your module, whatever you like. The example here shows module my. Obviously, that's not the correct reverse DNS name, but it's just to demonstrate. Yeah, you give it a name that will be universally unique. That's the idea. Now, there is one implicit module upon which you always have a dependency with, and it's Java-based. You don't even need to write that your module requires Java-based. It's implied anyway. Well, you can write it, but it's implicitly assumed that you do need Java-based module. As for any other modules, what do you need? Which other modules you require for your module, for your program? Well, you list them, yeah, requires, and write what other modules you want. Now, let's look at how to define module dependencies. So you probably figured out that it's done with requires keyword. Yeah? Requires specifies a normal module dependency. So my module needs something in another module. Huh? Okay, let's say I have some modules A, B, C, D, whatever. Yeah? And if module A says it requires module B, well, then you will have access to module B. It's possible that they will require module C as well, etc. Now, there's another interesting feature. It's called requires transitive. Requires transitive idea means that if module D says it requires module E, if it just says requires module E, that's not making it available to A if A requires D. But if D says requires transitive towards E, then any other module that requires module D will essentially also imply that it can access module E, so it's by proxy, if you like. Yeah. So module E becomes available to module A because D exposed it as transitive. All right. So that's kind of the gist of the requires keyword. There's also one more permutation of requires word, and it's requires static. Requires static indicates that a module dependency will be considered as important at compile time, but actually it will be considered optional at runtime. So you're not necessarily needed at runtime, but when you compile module A, you want to make sure that you reference in module F, for example. Yeah, that's required static idea. The next important part, kind of a counterpart, mirrored part of that relationship, is an exports clause. If module A requires module C, what exactly module C makes available to module A? There are packages inside each module. So module A says, I need stuff from module C. Module C says, I have a package X and I make it available to everyone. And I have package Y and I make it available only to some other module. Maybe to module B, I don't know. See, both modules A and module B in this picture require module C. And module B can access X and Y. And module C can only access X because the Y package in module C hasn't been made available to it. It has only been made available to specific other modules. So you kind of limit exactly what you expose from the module to the rest of the world. Yeah, once again, exports clause simply points to different packages. So classes inside these packages will be made available to other modules. All right. And if the module doesn't use the requires clause, like module D, for example, then we won't be able to see whatever module C exposes. Right? So there are two sides to this story. One module says, I need something from another module, which is requires. The other module says, I export something to you, which is exports. Yeah? And exports points to packages stored in that module. Moving on. Here's an example. Just, to put a bit more meat on these bones, yeah? Imagine you have a piece of Java code. Let's say there's some package called demos PM, yeah? And there's a class demos PM client there. And then there's another package, demos PM model, containing some classes like product manager and maybe some further package called data containing class product, maybe some utility package, etc. The trick is I want to put these two into different modules. For example, one of these modules, which is demos PM model, the one at the bottom, can represent my model, my business logic, data access, etc. Another module, which is that PM client at the top here, represents what, my front-end UI should look like. And in a module that's UI module, I create a dependency. I say, well, it requires the model. Yeah, it requires demos PM model. And in demos PM model, I export certain packages. I export the demos PM model package and demos PM data because I think they will be needed by the client. But I don't export this util thing, util package and a database, but because I think that should be something private to my model module. Yeah, so none of these clients' module business, I'm not exporting that. Essentially, it makes this util package, for practical purposes, kind of private to that particular module. That's the idea of what you're trying to achieve. All right, next. You may use another slightly different way of exposing the content of the module to the rest of the world. It's called an opened directive. It's kind of a counterpart of exports. Remember, export, you can export specific packages to everyone or to specific other modules. And opens, well, you can open the package to everyone or specific other modules. the difference between exports and open is that open makes types in a given package available to other modules via reflection API. So, for example, if module C in the packages X and Y contain classes you want to use with injections like injectable code, you know, CDI injections, yeah? CDI injections require code to be available through the reflection. And the exports instruction is not doing it. It's not making types available via reflection. So you need an opens instruction for that. There you go. Another option is to open an entire module. The command is called open module. Open module means you intend to make the entire contents of the module available for everybody via reflection. So no private packages, if you like, in that module C. Whatever it contains will be visible to whoever wants to use it. There you go. That's an open module. Finally, one more permutation of accessing contents and modules is the idea of a service. Imagine the module that describes an interface. And then there are, obviously, some implementation classes behind that interface. The idea is that a module info file describes that the module provides that interface with specific implementations. So another module could just say, oh, I'm going to use that interface. And that would allow you to kind of, import, if you like, or make available to that module A the implementations for that interface contained in module B. So that's kind of a gist of what's going on. You try to reference in a slightly different way, not just exporting the package, not just opening a module, but making specific services inside the module available to the external world. So this is it. These are the three ways of accessing module content. What else? Oh, that's an example of service, by the way. Just to give you an example of that. So imagine you have a client and it wants to use some kind of product manager class provisioned by the model module. So in the module, we have this product manager interface implemented maybe by, I don't know, database or file storage. By the way, here's another example of a transitive dependency. We factored out in this example the product class, which represents data probably managed by product manager, into a separate module. Since we make a transitive export, that means that any other module that uses the module that contains product manager would be able to access the module that contains your data, without actually the front-end client having to list it explicitly. It's enough a front-end client just says, oh, I'm going to use that service, and that would make the code of that pair of modules instantly available. So pick and choose. These are your module packaging options available from Java 9. Slightly different way of compiling code. So when you use a compiler, you could compile your Java sources, and instead of using class path, you could use modules path. It's a different environment construct. So you're specifying not the path to your jar files that contain your classes, but a path to module files that contain your classes. All right. So you could obviously package module itself. That's with the jar facility. So it's very similar to packaging classes into just normal jars. But the difference, remember, is that the module contains the module info class. Okay. And normal jars obviously don't. So it's described as a module. When you execute a modularized application, you don't set the class path. You set module path. And the module path is a list of paths that point to wherever jar files, locations of these jar files, which contain your modules. When you were packaging the module application, you could have specified where the main class is. If you want to execute it from command line, then you could just say -p and then execute the module. That's it. Yeah. So that would execute the module jar. If the main class hasn't been specified, then you have to specify the main class in command line parameter. Yeah. When you're running the application, say which class is your main class. What happens if you migrate code from earlier versions to this new sort of modularized environment? Well, apparently, those jar files that are old, non-modularized ones, without module info class, are sort of automatically presented to you as if they're modules. The module name will be derived from the jar file, so be careful. Give your jar files unique names. You'll be all right then. Also, you can control module names with manifest.mf file, if you like. Yeah? If you don't have manifest.mf file, then a module name will be derived from the jar file. And essentially, all jar files that are non-modules, from the earlier versions, are just sort of open for you. It's like creating an open module that you could just use from anywhere else, implicitly exporting all of their packages. So old code essentially still works in this new modular world, yeah, just with sort of no ability for you to restrict which particular packages you want to export. Yeah, it sort of exports everything, which is fine, for backward compatibility reasons. And then if you want to migrate the code properly to the new version, just create the module info classes and gain that control over exactly what is exported and what is made private to individual modules. The overall goal is to make your code more maintainable long-term, prevent clashes between versions of the application, class path clashes, split package clashes, yeah, etc. And finally, very closely related to the module idea, a new utility called JLink. What allows you to do is create a platform-specific executable file, JImage. Basically, you're saying that you want to take your modules and pack them into this image file, make an executable, which could be platform-specific. And the interesting thing is that you would not package the entire collection of your classes, but just those that are listed in module dependencies. So in other words, you would have a better control over the size of that runtime image. You can specify only those modules that actually need it, yeah, to be packed there. And the execution of Java runtime image is just as simple as that. Yeah, if you provided the module which contains the main class definition in there, then you don't need any further specification, just run the module name. Or if you didn't provide, you could say which class is your main class, essentially the command within the module which will correspond to what you want to execute. But you don't need a Java runtime in the launcher style image. Notice, yeah, no launcher, you use Java runtime on a client. With launcher, essentially the Java runtime is packed inside the module, so you just execute it from command line without having to pre-install the module on the client as such. Yeah, the Java runtime on the client as such. So that's a possibility now. Right. Well, there was a first section. We have to progress rather quickly. There was a first section on module design. So next section, a very quick one, is a JShell tool. It's a simple command line tool that allows us to execute Java code from line, yeah, in a kind of style where you type the statement and you kind of get an immediate feedback, read, evaluate, and print loop. These are the possible commands of the JShell tool. So you could just type Java code and execute it, and maybe run some scripts as well. So you can open pre-scripted code and execute that. The idea is that you can write code and execute it without having to form proper classes. You don't have to have a class with method main. You could just start typing what you... For example, if you want to test something, if you want to learn about certain constructs in the language, just a simple tool to do this kind of scripting. That's really it. It's pretty self-explanatory, and it's designed to simplify all of these cases where you want to try out some Java code without having to actually form, class with method main and just immediately evaluate and show the results. The version 10 for JShell contains some performance improvements that allow it to start a bit quicker. Apart from that, functionality-wise, it's the same as in version 9. So now, since version 9, we've got another interesting feature, which is called private interface methods. Basically, in the interface, you can now create a private method with the actual concrete code. In early versions of Java, you could have default methods, remember. Default methods are something that you may optionally override if you feel like it, but otherwise they provide default implementation. Well, the private method is something that you can't override. So maybe common logic that you want to share between other default methods can be placed into such private method. That's it. That's as simple as that. Try with resources improvement. A small improvement on top of what was already available in earlier versions of Java, which is when you open in a particular resource like this try block, and you are specifying that you want to, initialize some resource like this buffered reader, for example. The finally block, which closes this buffered reader, is automatically provided for you. Now, in early versions of Java, you have to initialize this new buffered reader statement, had to be inside a try block for the whole construct to correctly work. Otherwise, you risk the memory leak. Well, now you can initialize it beforehand, and it will correctly work. The implicit final block will correctly close that buffered reader variable for you. That's a small difference. Okay. Since version 10, not 9, a new feature called local type variable inference. Note the syntax. It kind of looks a bit like, JavaScript probably, and in a way, just a little bit, You have this var, then a variable name, and then initialization, which you actually don't have a type. So you're not saying that list or that string is of a particular type. The type is guessed from the right-hand side of expression. So, I don't know, array list of strings or a particular stream or whatever it is, the type is guessed for you. And you could use that particular technique for any local variable, variables that you declare inside your methods, essentially. Okay. Polymorphism is not really supported for that feature because variable will have not generic but specific type. It will be inferred from what you're assigned to the variable. You won't be able to override the type, fortunately. So basically at the time when the variable is initialized, that's where the type is determined, and that's it. The variable just becomes of that type. It's a simple way of kind of saving on typing, I suppose. You kind of have to type less. You could use that technique in local variables, in, variables that you describe in for loops or traditional or for each loops. Do not overuse the feature. It can reduce your code readability because you kind of start guessing when you read in the code. You don't know what the type of variable is until you read the assignment. So it certainly is convenient. It allows you to type a bit less, but use it with, a reason. Don't overuse it too much. a new feature which is currently in what we call incubator package, JDK incubator package. It will be eventually made into a standard feature into JavaNet HTTP package. It's probably by version 11, I guess. But at the moment, it's still an incubator technology. And it's an HTTP2 client. So we expect that to be obviously supported by the Java servers as well as, the server counterpart for it. So the feature works like this. An HTTP/2 is a new style of HTTP interaction between the client and a server. At the moment, you have to create a new HTTP client object and HTTP request, but as I say, in future versions, those classes that currently exist in JavaNet HTTP package will gain that ability. So you wouldn't have to, in the future, migrate your code that much. It allows you binary bidirectional connection between the browser, which opened a program that opened that HTTP2 connection, and a server. Transmitting data in binary data frames is obviously quicker than a plain text HTTP, and you can simultaneously upload and download content through the multiplex connection. It has some optimizations. For example, duplicate HTTP headers are not re-downloaded. Therefore, the overall amount of information that you need to download is smaller. And potential ability to do the server push because, as I say, the connection is bidirectional. So the server can send data to the client as well as client can send data to the server. And so therefore, it means that you can do asynchronous communications, as you can see from this code example, where you can handle the request-response interaction between client and server asynchronously. All right, so that's a new protocol, obviously, that we can now support. Now, we're entering the area of a variety of different API enhancements. Each enhancement is just kind of a more convenient way of achieving something or doing something. Yeah? So first area of enhancements that we're looking at is enhancements that we make to a stream. It's Java that's available from Java 9. Imagine you have a list of objects. Yeah, you added some objects to this list. And then there's an interesting method. It's called take-while. It's a new method. Yeah, that's the new feature. Take-while method operates on a stream. You set up the condition, the predicate. For example, price of product less than 3. Yeah, that's your predicate. And then you process each product. The trick is, it will stop processing that collection the moment the criteria is returning you false. Therefore, in a collection which has tea on 1.99, cake of 3.50, and coffee of 2.99, it will stop at cake and will not proceed to coffee. Yeah? Because the first occurrence of the clause yielding you false will stop the process. Okay? The opposite of that is called drop while. Yeah? Method process stream elements from that point at which it fails to specify the criteria. So we'll go onwards in the collection, yeah, from that point. Obviously, if the collection is unsorted, that means that you will just go to a particular point or from a particular point and process the rest of the collection, sort of dividing it by the criteria that you set. If the collection is ordered, well, then it guarantees potentially that you process all elements that satisfy particular criteria. But unless it's ordered, unless you sorted the collection first, that's not going to be the case. I don't know, for example, let's just think about a use case for it. I've got a series of scientific measurements, and I want to stop processing that series of measurements when a certain value arises. And I'm not interested if there are further measurements that match that criteria. I just want to stop the moment something happens, yeah? Or I want to process the collection onwards from the moment something happens. So this is the pair of take while and drop while. Let's take a look at the next one. It's a combination of two areas of enhancements, obviously processing a stream, but also working with an optional object. An optional object allows you to process content in a stream without actually crashing if it's null. So the syntax of applying a next method to a stream of data is potentially dangerous in a sense that if there's a null object within a stream, well, obviously you may have a null pointer exception. So the idea is that methods such as, for example, method find any, allows you to correctly handle that case. So this is a new feature. For example, a method filter potentially can return you an optional object. So there might be no such content in the stream. Find any method allows you to basically this is a filter. Find any method returns you the optional object. And the new feature is that you can now convert it again to stream. So maybe there's a further stream of data out there that you want to process. That's the new feature. Also, you may have alternative filterings. So, for example, in this case, I'm looking for products with a 0 price for whatever reason. That's my filter, Or I'm looking for products that price is greater than 10 or less than 5. So I've got alternative filtering conditions allowing me to build that stream of alternative supply clauses. Okay, that's the idea. And build a stream out of them. Next interesting point is a combination of optional class enhancements, again available in Java 9, and it performs actions upon the optional object. And the new feature here is this method called if present or else. So I'm looking for products with price greater than 5. I'm saying find me any product that matches that criteria. And then if I can't find it or I can find it, I want different actions. So if present, I want to print it. If not present, I don't know, I want to create a new object, for example. So any kind of roundable action at that stage. So that if present or else method is a new feature of the optional class. Continuing with the new methods and collection API, this time we're looking at Java 9 enhancements. It's a very simple method, really. A method called off. You can create a collection of values. An interesting thing is that you can just simply list whatever values you like. It could be a list of values, it could be a set of values, it could be a map of values, anything you want. And the point of the example here is that the method is overloaded for up to 10 entries, and then after that a var arg version is used, variable argument version of the method is used, for performance reasons, so it will quicker to initialize that collection. Also, duplicates are not allowed in these methods, so null values are not allowed, Well, for set or map, duplicates are not allowed, for list they're allowed. Null values are not allowed, and another important thing, resulting collection is immutable. So you get in a read-only collection of values here, which is really great if you want to do the thread-safe coding. Okay. You can also take any existing collection, which is normal mutable collection, and create an immutable collection out of it by calling the unmodifiable methods. Unmodifiable list, unmodifiable set, etc. So perform that conversion to get your sort of quick read-only collection out of any other collection that you have. And finally, a permutation of off method is called off entries. Off entries work similar to the method off, but allows you to create separate entries. If off method lists parameters just as comma separated list, for example, if you're creating a map, in the off method, you will have key value, key value, key value. So the key is 1, value A, keys to value B, etc. The auth method is just listing them all as one chain of parameters. Auth entries creates a separate entry, name value pair, for each element first, and then creates the collection of these entries, the map of these entries. Continuing with collection API enhancements, looking at Java 10. In addition to what we've just listed, in Java 10, we also have an ability to create unmodifiable list sets and maps using copy of method. So you can copy a collection to an unmodifiable list or set or map. Also, stream elements and modifiable collections can be created with two unmodifiable list, unmodifiable set, two unmodifiable set by a collectors class. Please note the difference. Please note the difference. In this example, some stream.collect method. So you're taking a stream and turning it to unmodifiable list or set or map. On the previous page, let me just jump to previous page for a moment. Yeah, there wasn't a stream, there was a list or set or map that you turned into unmodifiable list or set or map. Yeah, that's the example in orange. Yeah, so it wasn't a stream here in Java 9, and now you can do the same thing on a stream in Java 10. Yeah, turn a stream into read-only collection. Small but probably very convenient enhancements to the array class, arrays class. Arrays class now is a method called equals that allows you to actually compare the content in the array. So imagine you've got these three arrays, array A1, should be A2, sorry, I've probably just made a typo, so the second line should be A2, my fault. A2 and A3, right? Say I'm comparing A1 to A2, yeah, and because they have the same content, it says, yeah, true, they're equal. But if I compare A1 to A3, they're not, because they have different content. However, I may compare a fragment, it's highlighted in blue, yeah, fragments from different arrays, from position to position. So if I take array 1 and compare content from position 1 to position 4, and array 3 and compare the content from position 2 to position 5, they are B, C, D in both of the arrays, well, that fragment of these two arrays is the same, so equals method will return it true. The other interesting permutation of that particular technique is a method called compare and mismatch. They allow us to judge differences between arrays at looking at just the first mismatch. So compare allows you to find where the diff is, basically, and what the diff is. And there is an interesting technique here. A mismatch will tell you whenever the mismatch has occurred or not. Well, like -1, no mismatch occurred, or specific position, at which position mismatch occurred. Compare also allows you to return lexicographical difference. So if you compare array 1 and array 3, yeah, in array 1, the first element is A, in array 3 is X, so there are 25 letters between them. And you can basically tell the difference. Yeah, that's what compare method does. It returns you the diff in the positions here from lexicographical point of view. Yeah? So it's 25 character difference. All right. Also, a small permutation of the comparison operations. Compare unsigned in arrays 4 and 5. One of the values is positive and negative, but if you use compare unsigned, it will say it's true regardless. Yeah? It's basically ignoring the sign. Yeah? So these are enhancements to arrays class available from Java 9. Collectors. Right, let's take a look at that. Imagine you have a particular class. Let's say it's called order. An order is ordered by a particular customer. It has a date and it has a list of products. So imagine we have several orders. One made by Joe, by Bob, another made by Joe on a different date. Yeah. Okay. So we create a stream of these orders. What we can do with that stream? There is an interesting behavior here. It's called flat mapping. That's the first example. We group by orders by customer name. Yeah, let's say all orders that belong to Joe are grouped together. Yeah, all orders belong to Bob are grouped together. So that's grouping by clause. But then we do something interesting. We ignore the products coming from different orders, and we create a continuous list of products for every customer. So Joe has tea, coffee, and cake, regardless of the fact that it was actually in different orders. It doesn't matter. That's the flat mapping. All right? New method available from Java 9. The next method is called filtering. Eliminating content from the stream without removing an entire group. A normal filter method will remove the group if no criteria are yielded true for elements in that group. In this particular case, we're saying, I want to find out all orders made by my customers, yeah? But I only want to look at certain orders. I want to filter out those that were on whatever wrong date, yeah? So whoever made an order on the 22nd, I'm not interested. I'm interested in those who made orders on 21st. Lovely. So that's how I'm doing it. But if I use a filter method to do it, then I wouldn't know that, that there was a case for, sorry, did I say I'm not interested in 22nd? I'm interested in those orders. Say it again. I'm interested in those orders that were made on 22nd. I'm not interested in those orders that were made on 21st. Yeah, that's right. Just reading the clause. Equals to 22nd. So, if I would use a simple filter method, I will lose information about Bob, because Bob never made an order on the 22nd. The only order that Bob made was on 21st. But I want to know the fact that Bob made orders, even though I don't want to know what these orders are. That's the difference between filtering. It does not discard the group. The group for Bob, grouping by customer, still remains. It's not trashed. Yeah? Well, you know, it's just an interesting permutation of behavior, I guess. We're approaching a few more features here. The object class enhancements. Objects class allows you to substitute a value, require, none, or else, or require none, or else get. Get basically provides a supplier which manufactures the value. Yeah? So if something is null, you can substitute a dummy. Yeah? Another interesting method, checking the index. Instead of crashing with index out of bounds exception, you could say, actually, let's check if I'm getting out of bounds. Yeah? Before I access a particular collection, for example. Or it could be applied to collection, it could be applied to string. You can check if text length is in particular boundaries. Okay. Scanner. Scanning the content, splitting it into tokens, so you can specify a delimiter, and processing tokens as stream of tokens. Looking for things inside a stream with find all methods. Find all method allows you to use regular expression. You can pre-compile it with part and compile, but if you just supply it as a string, as the example above, then it will still be compiled to regular expression pattern. So it's basically a quick way of searching through a text with regular expressions, just a convenience method. A little bit more interesting, I guess, which is asynchronous stream processing. When you process a stream content, you can create subscribers, publishers, and processors for the stream. A subscriber, for example, could have methods that process the content like next, element in the stream, yeah, or onComplete when you finish processing, or what to do when there's an error occurring, on error. And you basically can create a subscription and supply the subscriber to process the content of the stream. So subscriber can receive content, process that. It's important that it's non-blocking calls. Processing the content of the stream in a separate thread, essentially. Publisher can create content in the stream, again, in a separate thread. Processor can do both, subscribe and publish elements to the stream. So it's an asynchronous way of processing the stream content. It works probably together with utilities such as fork join framework, which is itself not a new feature, I guess, but just this automation on the streams, yeah, that allow you to create a convenient way of processing them asynchronously. Some request handling, process handling enhancements with the class JavaLang process allows you to monitor processes that are, other processes outside of your Java virtual machine, access them, look at their process IDs, look at how they support termination, what to do on exit, are there any child processes, descendants, etc. So this is a collection of new methods that's available for handling such processes. Walking the stack, you could trace the method call. So get a stack walker object and then start walking the stack with a walk method, yeah? And you can have a condition there, like filtering out or elements. So in this particular case, for example, I'm looking for the beginning of the stack, find first method, yeah? So who called me? That's what this program answers, yeah? I'm invoked by some program test, method name, line number 30. Yeah, that's literally what the answer is. And if you don't do the find first, then you see the entire trace. Every method called and every method on which line it occurred. So it's kind of a programmatic way of identifying how you arrived at a particular place in the program through analyzing the stack. This is a reference manipulation API. Enhancements done in Java 9 to manage phantom references and reference queue. It's basically manually clearing the pointers. So you can use a thread factory to perform a memory cleanup manually, yeah? With phantom and references. The cleanable objects need to implement the cleanable interface, the method clean, and then you can register cleanable objects with your cleaner API, and therefore be able to kind of more manually manage the data cleanup. Some small enhancements to support of lockouts, apart from country, language, etc. You now have calendar, number, and in Java 10, currency, first day of the week, region, and time zone overrides. They're supported by all locale-related classes such as date, number, format, calendars, yeah, etc. There you go. Memory management enhancements. Since Java 9, we have a new garbage collector, yeah, the G1. G1 is a full parallel garbage collector, which can be controlled with the from Java 10. It can be controlled with additional command line parameters called parallel GC threads. Yeah, and since Java 10, it basically can use parallel threads to clean up your memory. Garbage collection process has been significantly speeded up. Yeah, it basically works quicker by splitting memory into pages and concurrently in different threads, garbage collecting data from these pages, yeah, from different memory segments. Okay. Also, there's another interesting feature called heap allocation on alternative memory devices. Allows you to use, for example, video RAM to allocate parts of the heap. Yeah, it's obviously slower than your normal RAM, but then you can take more memory in the program. Okay, so there you go. Oh, and new garbage collector interface. Basically, if you're writing your own garbage collectors, like you're implementing your own Java virtual machine features, you know, on a language level, I guess, yeah, then there's a streamlined way of creating further garbage collectors, which is kind of standard way of doing it through a standard simple interface that you can now implement. Other management and performance enhancements. Enabling the Growl just-in-time compiler for Linux platform that allows you to, kind of use experimental mode, if you like, to create a platform-specific executable in Java for Linux for a moment. Then, thread local handshakes. Again, that's a feature that's not yet available on other platforms, but x64 and Spark. So to become available in future for other platforms, improving the time it takes for virtual machine to perform communications between threads. in a way that would not require JVM to perform a save point and stop all memory, to perform such, stop all threads to perform such handshakes, for global synchronization. So it will improve the overall concurrency sort of capabilities in the program. Slight enhancements, I guess, about a convenience on the root certificates in JDK. Previously, in OpenJDK, there were no pre-supplied root SSL certificates, but they were supplied in Oracle JDK, but not in OpenJDK. Basically, we made our certificates available for the OpenJDK. In terms of the JDK development itself, various JDK repositories has been combined together into one single development repository, and also in terms of how you manage your code, the native header generation tool, JavaH, has been removed because now JavaH does the same thing, so there's no need for JavaH tool anymore. It's gone. If you're using Java Virtual Machine with a Docker, there are some enhancements in Java 10, please note, that basically allow Java Virtual Machine to find out how you set up the Docker. So access to host memory, access memory limits set on the Docker, Docker parameters on, setting up CPU cycles or number of CPUs available, etc. So Java Virtual Machine is now aware of these parameters. It's not using your OS, it's using what the Docker tells it. These values. Wow, well, I guess that's it. I mean, it has been a very dense presentation, as you probably noticed. A lot of features to cover. But that's it from me for now. So we looked at a Java modular design, a JShell, and a variety of different language and API enhancements. Thank you very much for your attention.